Welcome back to my YouTube channel. In this video, we are going to see about a differential pressure transmitter. First, what's meant by a differential pressure transmitter? It is a device that measures two opposing pressure in a pipe or vessel. A differential pressure, called as a delta P or dP transmitter, is industrial standard terms for measuring a differential pressure. So delta means change in and P means pressure. So most commonly called in industry as a DP sensor or a DP transmitter. Let's look at the working of a DP transmitter. A DP transmitter is a pressure measuring gauge or electrical device that uses two elements to measure a difference of pressure in a sealed container, such as pipe. DP transmitter will have a primary element, secondary element, and an electrical housing. The primary element will produce a difference in the pressure as the flow in the pipe increases. Different types of primary elements include orifice plates, venturi tubes, flow nozzle, and biddage elements. The secondary element will measure the difference of pressure produced by the primary element as accurately as possible. The primary element is sometimes called as a high side and a secondary element called as a low side. It is important to remember that the high side and low side are not always on the respective high and low pressure sides at the pipe. The element in a DP transmitter will have a sealed diaphragm and one of several ways to convert the pressure applied on the diaphragm into electronic signals. Sensors such as a differential capacitance, vibrating wires, or a string gauge are used to produce electrical signals that will be sent to the electronic housing, where it is processed, converted, and amplified into a current or voltage signal output. They can be read by the control system. The electrical output generated by the DP transmitter electrical module is linear and proportional to the actual measured delta P. Depending on the range of measured pressure, 4 milliamp signal could equal to a measured delta P of 0 psi, and a 20 milliamp signal could equal to the maximum measured value. In this case, we will say the maximum value is 100 psi. Using this variable, we must know a 12 milliamp signal is equal to 50 psi of a delta P. The relationship between a produced electrical signal to the unit of measured is called scaled output. Let's look at the application of a TP transmitter. TP transmitters are widely used in a flow measurement applications, such as measuring the flow of fluid or gases through a pipeline and channels by using orifice plate. They are employed for a level measurement in a tank and vessel, providing indirect measurement based on hydrostatic pressure of the fluid. DP transmitters are utilized in a system where maintaining a specific pressure is critical, such as controlling a pressure in a steam boiler. In some cases, TP transmitters are used to measure a density by considering the pressure difference in a fluid or known for a composition. Commonly used in a differential pressure flow meters, including orifice plates, venturi tubes, and flow nozzles. Differential pressure transmitter is capable of measuring both the positive and negative pressure difference. The key characteristics of a TP transmitter is its ability to measure the pressure variance between the 2 points in a system, where the results in a positive or negative differential pressure. Let us look at the advantages of a DP transmitter. DP transmitters are versatile and can be applied in various industries for a different purpose, from a flow measurement to a level control. When properly calibrated and installed, a DP transmitter provides accurate measurements, make them suitable for a critical process. The standardized output signal, typically a 4 milli to a 20 milliamps, allows for a capability with a various control system and indicators. Compared to some other types of a flow measurement device, TP transmitter can be cost-effective, especially in application with moderate accuracy requirements. Some differential pressure transmitter offers a capability to measure multi-variables simultaneously, such as differential pressure, static pressure, and temperature. Let us look at the disadvantages of a TP transmitter. Installation and proper positioning of a TP transmitter and associated with the elements such as orifice plate can be critical for accurate measurements and adding a complexity to a setup. Periodic calibration and maintenance are necessary to ensure continuous accuracy. Falling or damage to the sensing element can be affect the performance. DP transmitter may have a pressure limitation, especially in a high pressure application. In such a case, alternative pressure measurements technology might be more suitable. Extreme temperature can affect the accuracy and performance of a DP transmitter. In a dynamic process with rapid changing conditions, the response time of a DP transmitter may be limiting factor. And the final summary of a differential pressure transmitter plays a crucial role in measuring a pressure difference across a 2 point in a system, make them invaluable in various industrial process and control systems. It offers versatility and accuracy in measuring a pressure difference. Proper installation, maintenance, and consideration of a limitation are essential for their efficiency uses in a different application. It is versatile and it can handle a situation where the pressure difference is either positive or negative. This makes it suitable for a wide range of applications from measuring a flow rate to monitoring a level in tank or a control pressure in a various process. And that's all about a differential pressure transmitter. Thanks for watching.